Okay, so we're doing adding and subtracting vectors. Our first question here, it says, in still water, I'm not sure why that's capitalized, but in still water, Maria can paddle at the rate of 7 kilometers an hour. The current in which she paddles is 4 kilometers an hour. At what velocity does she travel downstream? So when talking about a river, downstream is when you're traveling with the current. So we imagine, this chair's shaky, I don't like this. Current itself travels at 4 kilometers an hour. And this is the direction. We're going to say it's to the right for now, okay? So she's not paddling in any type of way where, let's say this was the river. She's not doing anything like this where she's going across the river. She's going parallel to everything. Should have been like that. Okay. So she's on top of the water on her boat. Okay. And she can travel at 7 kilometers an hour in the very same direction. So since she's parallel to this, we're going to call this 7 kilometers an hour. We'll call this vector A, and we're going to call the river vector B. Okay. Now, when she's traveling downstream, what is happening to the vectors? What operation would we be using with them? Adding. We're going to be adding these two vectors together. So essentially our question is, we will call it vector C. And what we're going to do is we'll use 2 lines to represent these. We have our vector A, and then we'll do it in blue. This will be our vector B. And it's going to create, essentially, and we'll draw it underneath what vector C will be. We'll do that in red. Okay. So in other words, our vector A plus vector B is going to be the equivalent of our new vector C. And since they're all parallel to each other, they're all going to be heading in the same direction. Okay? So, in order to add these two together, what's happening with her speed in this case? It's increasing. Her magnitude. So, her magnitude in A, okay, so first one, is 7 kilometers an hour. And we're adding that magnitude to what? 4 kilometers an hour. So, at what magnitude or speed is she heading downriver now? 11 kilometers an hour. That one's pretty straightforward. Okay, it just adds directly to it. Because they're parallel to each other, we just connect them at the ends of each other, right here. And the magnitude of the vector increases by the exact amount that they are. This one is 7, this one is 4. Had the direction of the vector been a little different, say she'd been traveling due west on the river, and the river's current was actually going in a northeast direction. Whoops. Was going in a northeast direction. That would have changed it. Our resultant vector would be what those two would be adding up to, or what direction she'd be heading. But because they're parallel, she's heading downstream with the river, we just add the two of them together. Using vectors, draw a diagram to illustrate this. That's exactly what we just did. We just illustrate this with 2 vectors, where we had vector A plus vector B was the equivalent of vector C. Okay, and vector C was her speed when traveling downstream of the river. Question C wants us to do the exact same thing. They want us to repeat what we did above, but going upstream. So in other words, again, we still have vector A, and we're going to represent it with our vectors. So let's call this question B. Upstream now, okay? Our vector A, she still travels at a direction of 7 kilometers an hour. Well, what's happening to the current now in this question? Anyone know? It's going the opposite direction of us now. Okay? So there's 2 ways we can represent this. We can say maybe the current had changed. It was going one way and then it turned the other. And we'll try to put these to scale. So this is 4 kilometers an hour. So as you notice, when we tried to scale it, it's not perfect, but the 7 kilometers an hour we've drawn is a longer vector because it has a larger magnitude, and essentially a magnitude of unit 7, where our river vector is going the opposite direction and is a smaller drawn vector in terms of the scale of it because the magnitude is 4 compared to the 7 kilometers an hour. Okay, so what we can do to represent this, again, is first off, change it to black. We have 7 kilometers an hour. And then what's happening is we're being slowed down because we're going upstream of the current. And what happens is that current, and we'll try to draw it right on top, superimpose it here, is going 4 kilometers an hour. Okay, so it's like we started here, went to here, if we're adding them, and came back. So what happened is our A vector, we'll say we're still traveling in the same direction, is now being added to what? How can I represent the B vector? Negative B. Negative B vector, or we can write the question as A subtract B. Both are the same thing, right? We talked about that before. So what is the resultant magnitude of this? Or what speed is she traveling at in the boat? How would we solve this? We're going to subtract the two. So magnitude of A is 7. And subtract the 4 kilometers an hour. How fast is she moving? 3 kilometers an hour. What direction is she heading? She's still heading in the same direction, which in this case is east. It's possible, had it been vice versa, she was trying to travel east, and if the river's vector was something like 14 kilometers an hour, it would cause her to actually end up going the other way because she wouldn't be able to keep up with the current. Something like maybe whitewater rafting, if she was trying to go upstream and something like that. That's what would happen here. Are you guys okay with that question?